66 million years ago, the dinosaurs disappeared, and Earth entered a very different chapter. Forests slowly changed, new animals spread across the land, and the world became cooler over millions of years. Huge sheets of ice eventually covered large parts of the planet, changing rivers, mountains, coastlines, and the lives of every creature that survived. Giant mammals walked across frozen plains, early humans learned to live through harsh winters, and changing climates shaped the world we know today. "66 million years ago, a huge event changed life on Earth in a way that no living thing could stop. At the end of the Cretaceous period, a very large asteroid struck the area that is now part of Mexico, near the Yucatan Peninsula. The impact released an enormous amount of energy into the air, the land, and the sea. It sent huge amounts of rock, dust, ash, and tiny particles high into the atmosphere. Fires spread across many regions, earthquakes shook the ground, and giant sea waves rushed across coastlines. Plants and animals that had lived for millions of years suddenly faced conditions that made survival very difficult. The skies became darker because sunlight could not easily pass through the thick layer of dust. Temperatures dropped in many places because less sunlight reached the ground. Plants could not grow well without enough light, and this caused food supplies to become smaller across many environments. Many kinds of dinosaurs disappeared during this time. All of the large non-flying dinosaurs became extinct. Only a small group of feathered dinosaurs survived. These survivors later continued to evolve into the birds that live around the world today. Their survival depended on many factors, including their smaller body size, their ability to eat different kinds of food, and the places where they lived. Many other animals also disappeared, including flying reptiles called pterosaurs, and many sea reptiles that had ruled the oceans. Large numbers of sea animals also died because the food chains in the oceans were badly damaged. The first years after the asteroid impact were extremely difficult. Forests that had covered large areas were destroyed by fire or died because sunlight became too weak for healthy plant growth. Leaves fell from trees and many plants stopped growing. Animals that depended on fresh leaves, fruits, seeds, and flowers struggled to find enough food. Plant-eating animals became fewer, and meat-eating animals also lost their food sources. The loss spread from one part of nature to another. Small living things that depended on larger animals also faced serious problems. Even though many species disappeared, some forms of life managed to survive. Small mammals remained alive by hiding in underground burrows, rock shelters, hollow logs, and other protected places. Many of these mammals ate seeds, insects, roots, worms, fruits, and other foods that remained available even after many plants had died. Their small bodies needed less food than large animals. Many were active at night or lived quietly in hidden places, helping them avoid dangers during the difficult years after the impact. Birds also survived in several parts of the world. Some birds lived near rivers, lakes, and wetlands where food remained available. Others fed on seeds that stayed in the soil or insects that survived the disaster. These early birds became the ancestors of the thousands of bird species that now live across every continent. Their feathers helped protect them from changing weather, and their ability to fly allowed some of them to move to places with better food supplies. Freshwater environments became important places for survival. Rivers, lakes, and ponds continued to support fish, turtles, frogs, salamanders, crocodiles, and many kinds of insects. Water plants slowly recovered after the skies became brighter again. Small animals living in freshwater often found shelter among plants, mud, rocks, and fallen branches. These places protected many species during the difficult period that followed the asteroid impact. Crocodiles survived because they could live with less food for long periods. Their slow way of using energy allowed them to stay alive when prey became scarce. Many crocodiles rested quietly in rivers and wetlands until food became easier to find again. Turtles also survived because many lived in water, where conditions remained more stable than on dry land. Their shells protected them from many dangers, and they could eat different kinds of food depending on what was available. Amphibians such as frogs and salamanders also remained part of the changing world. Many laid eggs in water, where young animals developed safely. Their small size allowed them to hide beneath leaves, in wet soil, or under stones. Many insects survived as well. Beetles, ants, termites, flies, and other insects continued living in forests, wetlands, and underground. They played an important part in breaking down dead plants and animals, returning nutrients to the soil where new plants could grow. As the dust slowly settled from the atmosphere, sunlight gradually reached Earth's surface once again. Plants slowly began growing in many places. Small plants often appeared first because they could spread quickly. Ferns became especially common in areas where forests had been destroyed. Their spores traveled easily through the air and quickly covered empty ground. Scientists have found evidence of this period in rocks because many layers contain very large numbers of fossil fern spores. These fossils show that ferns became some of the first plants to spread across damaged landscapes. After ferns covered the ground, other plants slowly returned. Mosses, grasses, shrubs, and young trees started growing where enough sunlight and water were available. Forests slowly formed again, although they looked different from those that had existed before the extinction. New groups of flowering plants spread into many regions. They produced seeds, fruits, and flowers that supported insects, birds, and small mammals. As plants became more common, insects also increased in number. Bees, butterflies, flies, beetles, and many other insects visited flowers to feed on nectar or pollen. While moving from flower to flower, they carried pollen that allowed plants to reproduce successfully. This relationship helped many flowering plants spread across the land. Forests became richer with different kinds of plant life, creating homes for many animals. Mammals were among the animals that gained the greatest opportunities after the disappearance of the large dinosaurs. During the age of dinosaurs, most mammals had remained small because large reptiles dominated many environments. After the extinction, many habitats became empty. Food sources that had once been used by dinosaurs became available. Mammals slowly moved into these open environments and began developing many different ways of life. Some mammals stayed on the ground, searching for seeds, fruits, insects, worms, and small animals. Others climbed trees where they found safety and food among branches. Some became fast runners that crossed open land. Others dug underground tunnels where they escaped predators and changing weather. Over many millions of years, mammals became more varied than ever before. Different teeth allowed mammals to eat different foods. Sharp teeth helped meat-eaters catch prey. Flat teeth allowed plant-eaters to crush leaves and seeds. Some mammals developed mixed teeth that allowed them to eat many different foods. This flexibility helped many species survive changing conditions because they were not limited to a single food source. The brains of mammals also continued developing. Better hearing, stronger senses of smell, and improved learning abilities helped them find food and avoid danger. Mothers cared for their young by feeding them milk, protecting them from predators, and teaching them important survival skills. This close care increased the chances that young mammals would survive until adulthood. The climate also changed over time after the extinction. During the first period after the impact, cooler temperatures affected many regions because sunlight was blocked. Later, as dust disappeared and volcanic gases remained in the atmosphere, temperatures slowly became warmer again. Earth experienced many climate changes over millions of years. Some places became wetter, while others became drier. Forests expanded into new regions, while open woodlands and grasslands slowly appeared in other areas. The continents continued moving because Earth's tectonic plates never stopped shifting. Land that had once been connected slowly moved farther apart. Oceans widened in some places, while mountain ranges rose in others. These changes affected weather patterns, rainfall, river systems, and ocean currents. Animals and plants living on separate continents gradually became different because they were no longer able to mix with populations living far away. The oceans also slowly recovered after the extinction. Tiny sea organisms called plankton returned in increasing numbers as sunlight reached the surface again. These tiny living things became food for many larger animals. Fish populations slowly increased. Coral reefs gradually recovered, providing shelter for many sea creatures. Sharks survived the extinction and continued swimming through the oceans. Many kinds of shellfish, sea stars, sea urchins, and crustaceans slowly became common again. Whales did not yet exist immediately after the dinosaurs disappeared. They would evolve much later from mammals that originally lived on land. At first, the oceans were mainly filled with fish, sharks, rays, shellfish, and many smaller sea animals. Over millions of years, new groups of marine mammals appeared and adapted to life in the water. Birds expanded into many habitats after the extinction. Some birds remained in forests, feeding on fruits and insects. Others lived near rivers and lakes where they caught fish. Some developed strong legs for running across open land, while others became excellent flyers capable of traveling great distances. Their beaks became different shapes depending on the food they ate. This variety allowed many bird species to live in the same region without competing for exactly the same food. Flowering plants became one of the most successful groups of plants during this period. Their seeds spread through wind, water, and animals. Fruits attracted birds and mammals, which carried seeds to new places. Flowers attracted insects that helped with pollination. These natural processes allowed flowering plants to become common across much of Earth's land. Insects continued becoming more diverse. Ant colonies grew larger and developed organized societies with workers, soldiers, and queens. Termites built underground homes and helped break down dead wood. Bees became important pollinators. Butterflies and moths spread pollen while feeding on flowers. Beetles fed on wood, leaves, flowers, dead animals, and animal waste, helping recycle nutrients throughout many ecosystems. Many reptiles also remained successful after the extinction. Lizards spread into deserts, forests, rocky hills, and grasslands. Snakes continued evolving into many different forms. Some hunted by squeezing prey, while others used venom. Turtles remained common in rivers, lakes, oceans, and on land. Crocodiles continued living in wetlands where they hunted fish, birds, and mammals that came near the water. The forests that developed after the extinction supported growing numbers of animals. Tall trees formed thick canopies that shaded the ground below. Bushes, vines, mosses, fungi, and ferns covered lower levels of the forest. Birds nested in branches, insects fed on leaves, mammals climbed trunks, and reptiles searched among roots and fallen logs. Every layer of the forest provided homes for different living things. Fungi became especially important after so many plants and animals had died. They broke down dead material into simple nutrients that entered the soil. These nutrients allowed new plants to grow more successfully. Without fungi and bacteria, dead plants and animals would have remained much longer, slowing the recovery of forests and grasslands. Without fungi and bacteria, dead plants and animals would have remained much longer, slowing the recovery of forests and grasslands. The recovery of life did not happen everywhere at the same speed. Some regions recovered more quickly because they received enough rainfall and had healthier soils. Other places remained damaged for much longer. Local conditions such as climate, rivers, mountains, and nearby oceans affected how quickly plants and animals returned. As millions of years passed, mammals increased greatly in size and variety. Some became large plant eaters with strong legs for walking across forests and open land. Others became powerful hunters with sharp teeth and fast movement. Some lived entirely in trees, using their hands and feet to grip branches. Others became excellent swimmers that spent much of their lives in rivers and lakes. Primates also appeared during this long period. Early primates were small mammals that spent much of their time in trees. They developed hands that could grasp branches, eyes that faced forward, and brains that became larger over time. These features helped them move safely through forests and locate food. Many millions of years later, one branch of these primates eventually led to humans. Earth continued changing through natural processes. Volcanoes erupted in different regions, adding new rock to the surface. Rivers carried sand and mud across valleys. Wind shaped deserts and rocky landscapes. Glaciers formed much later during colder periods, carving valleys and moving huge amounts of rock. Every change created new environments, where plants and animals continued adapting. The atmosphere also continued changing. Plants absorbed carbon dioxide and released oxygen through photosynthesis. Forests helped shape the balance of gases in the air. Oceans also absorbed large amounts of carbon dioxide, affecting global temperatures over long periods. Tiny marine organisms played an important role in these natural cycles. Many groups of animals that are familiar today have their roots in the time after the dinosaurs disappeared. Hoofed mammals, bats, rodents, rabbits, elephants, horses, cats, dogs, whales, seals, and many other groups evolved over tens of millions of years. Each group adapted to different environments and food sources, as Earth's landscapes continued changing. Bats became the only mammals capable of true powered flight. Their wings, formed from thin skin, stretched across long fingers. They hunted insects, ate fruit, drank nectar, or caught fish depending on the species. Many became active at night, using sound to find objects and prey through echolocation. Rodents became one of the most successful mammal groups because they reproduced quickly and could live in many different habitats. Their strong front teeth continued growing throughout life, allowing them to gnaw seeds, wood, roots, and many other materials. They spread across forests, grasslands, deserts, mountains, and wetlands. Large grazing mammals appeared after grasses became widespread. Grasslands supported herds of animals that fed mainly on grass. Predators followed these herds because they provided dependable food sources. These changing environments shaped the evolution of speed, endurance, strong teeth, and social behavior in many mammal species. Ocean life also continued developing. Marine mammals evolved from land mammals that gradually returned to the sea. Early whales still had small legs that became less useful over time as their bodies adapted for swimming. Their nostrils slowly moved toward the top of the head, eventually becoming blowholes. Their front limbs became flippers, while their back legs became much smaller. Birds continued filling many ecological roles once occupied by other animals. Large flightless birds lived on some continents, while small songbirds spread through forests and woodlands. Birds of prey hunted mammals, reptiles, and other birds. Water birds searched rivers, lakes, and coastlines for fish and shellfish. Their feathers helped regulate body temperature, allowed flight in many species, and protected them from rain and cold weather. In every generation, living things passed useful traits to their young through reproduction. Small changes accumulated over millions of years, leading to the development of new species. Some species survived changing conditions, while others disappeared. Extinction remained a normal part of Earth's history even after the end of the dinosaurs. Fossils formed during these millions of years provide important evidence about this changing world. Bones, teeth, footprints, leaves, pollen, shells, and burrows became buried beneath layers of mud, sand, or volcanic ash. Over time, minerals replaced much of the original material, creating fossils that scientists study today. These fossils reveal how plants, animals, and environments changed after the extinction event. Rock layers from different regions help scientists understand the order of events after the asteroid impact. Certain layers contain high amounts of the element iridium, which is rare in Earth's crust but more common in asteroids. This evidence supports the idea that a giant asteroid played a major role in the extinction. Other rock layers show the return of plants, insects, mammals, birds, and many other forms of life as Earth's ecosystems slowly recovered. Every continent preserves evidence from this important period. Fossils discovered in North America, South America, Europe, Africa, Asia, Australia, and Antarctica reveal that recovery happened across the entire planet. Each region had its own climate, plants, and animals, yet all experienced the effects of the mass extinction and the gradual return of life. Mammals had already existed while dinosaurs ruled the land. They were not new animals that suddenly appeared after the extinction of the dinosaurs. Their ancestors had lived alongside dinosaurs for a very long time. Most early mammals were small, usually no larger than a mouse, a rat, or a small squirrel. Many of them were active during the night. Being awake after sunset helped them avoid many dangerous predators that hunted during the day. They often searched for insects, seeds, fruits, worms, and other small food sources. Their small size allowed them to hide in holes, under rocks, inside fallen logs, and among thick plants. These early mammals had several useful features that helped them stay alive. They had warm bodies that could produce their own heat, allowing them to remain active even when temperatures changed. They were covered with hair or fur, which helped keep them warm. Mothers produced milk to feed their young, giving newborn babies an important source of food during the earliest part of life. Most mammals also cared for their young for a long time, protecting them from danger and teaching them how to survive. This care greatly increased the chances that young mammals would reach adulthood. When the asteroid impact caused the extinction of many large animals, the environment became difficult for almost every living thing. Dust and tiny particles filled the atmosphere and blocked much of the sunlight. Plants struggled to grow because they received less light. As plants died, many plant-eating animals also died from lack of food. Meat-eating animals soon faced starvation because their prey became scarce. Food chains across both land and sea were broken. Many habitats changed as forests were damaged and climates shifted. Small mammals had several advantages during this difficult time. Their bodies required less food than those of giant animals. They could survive by eating many different kinds of food instead of depending on only one source. Some ate insects that continued to survive. Others fed on seeds, roots, nuts, dead animals, fungi, or whatever they could find. This flexible diet helped many species remain alive during a period when food was difficult to find. Many mammals also lived underground in burrows. These underground homes provided protection from heat, fires, falling debris, and changes in weather. Inside their burrows, temperatures remained more stable than above the ground. These shelters also protected them from many predators. Some mammals stayed hidden for long periods while waiting for conditions on the surface to improve. This ability to shelter underground became one of the reasons why many mammal groups survived when so many larger animals disappeared. As the skies slowly cleared and sunlight returned, plants began to grow again. New leaves appeared on surviving trees. Flowers spread across many regions. Grasses had not yet become as widespread as they would later become, but many other plants started covering the land. Forests slowly recovered. Rivers, lakes, and wetlands became home to fresh life. Insects multiplied once again, creating new food sources for many animals. The disappearance of large dinosaurs left many empty places in nature. Areas that had once been occupied by giant plant eaters and large predators no longer had those animals. Food sources became available to new species. Places to live opened across forests, plains, rivers, mountains, and coastlines. Mammals slowly expanded into these empty environments. Over many generations, they evolved new body shapes, new diets, and new ways of living. Natural selection guided these changes. Individual animals that had useful traits were more likely to survive and have young. Those useful traits were passed on to future generations. Over many thousands and millions of years, small changes accumulated. Bodies became larger or smaller depending on what helped survival. Teeth changed shape to handle different foods. Legs became better suited for running, climbing, digging, swimming, or jumping. Eyes and ears became more specialized. These gradual changes produced many different kinds of mammals. Some mammals remained small and continued eating insects. Others began feeding mainly on fruits. Some specialized in leaves, while others became hunters. Different food choices reduced competition between species because each group found its own source of food. This allowed many different mammals to live in the same general area without relying on exactly the same resources. The forests that spread during the early part of the Cenozoic era provided excellent homes for tree-dwelling mammals. Strong branches offered safety from many predators and access to fruits, flowers, leaves, and insects. Mammals living in trees developed features that helped them climb. Some evolved longer fingers that could firmly grasp branches. Others developed flexible shoulders and powerful limbs. Better balance allowed them to move confidently through the forest canopy. Some of these tree-dwelling mammals eventually became early primates. Their hands became more skilled at holding objects. Their eyes gradually moved towards the front of the face, improving depth perception. Better vision helped them judge distances between branches while climbing. Larger brains supported more complex behavior, learning, and memory. These early primates represented the beginning of a long line that would eventually include monkeys, apes, and humans. Other mammals adapted to life on the ground. Some became swift runners, able to travel long distances while searching for food. Their legs became longer, and their feet changed to support fast movement across open land. Hooves developed in several groups, providing strength and support while running over firm ground. These early hoofed mammals later gave rise to many familiar animals, including horses, deer, cattle, pigs, camels, rhinoceroses, and many others. Plant-eating mammals faced constant danger from meat-eating animals. As herbivores became faster and more alert, predators also evolved. Sharp teeth, powerful jaws, strong muscles, excellent hearing, and keen senses of smell became important hunting tools. Different hunting methods appeared. Some predators chased prey over long distances. Others remained hidden until the right moment before attacking. Some hunted alone, while others later evolved social behavior that allowed them to hunt together. Among the earliest successful predators were ancestors of modern carnivorous mammals. Over time, they developed specialized teeth for cutting meat. Their claws became sharper, flexible bodies allowed quick movement. Sensitive ears detected small sounds, while excellent eyesight helped locate prey. These features allowed carnivorous mammals to spread across many parts of the world. Some mammals developed powerful digging abilities. Strong front legs and large claws helped them dig tunnels beneath the ground. Underground life protected them from weather and predators. Burrows also provided safe places to raise young. Animals that spent much of their lives underground developed sensitive noses and whiskers to help them find their way through dark tunnels. Water also became home to many mammals. Some species spent increasing amounts of time near rivers, lakes, and coastlines. Their feet gradually became better suited for swimming. Thick layers of body fat helped keep them warm in cold water. Their tails became stronger for movement through the water. Nostrils shifted position over time, allowing easier breathing while swimming near the surface. One remarkable group of mammals eventually evolved into whales. The earliest ancestors of whales lived on land and walked on 4 legs. They probably searched for food along riverbanks and shallow coastal waters. Over millions of years, they spent more time swimming. Their front legs slowly changed into flippers. Their back legs became much smaller and eventually almost disappeared. Their tails developed large horizontal flukes that provided strong forward movement. Their nostrils gradually moved toward the top of the head, becoming blowholes. These changes allowed whales to become fully adapted to life in the oceans. Other mammals evolved into seals, sea lions, and walruses. These animals divided their time between land and water. Their flippers allowed efficient swimming while they still returned to land or ice to rest, breed, and care for their young. Thick layers of fat protected them from cold temperatures. Flying mammals also appeared. Bats became the only mammals capable of true powered flight. Their wings formed from skin stretched between greatly elongated fingers. Flight allowed bats to reach insects, flying through the night sky, flowers filled with nectar, fruits hanging from trees, and many other food sources. Many bats also developed echolocation, producing sounds and listening for echoes that bounced back from nearby objects. This ability allowed them to fly and hunt in complete darkness. As mammals spread across different environments, body sizes became increasingly varied. Some remained tiny enough to fit inside small spaces. Others became among the largest land mammals that ever lived. The size of each species depended on available food, climate, predators, and other environmental conditions. Large plant eaters needed abundant vegetation, while smaller animals often survived on limited food supplies. Climate continued changing throughout the Cenozoic era. Temperatures rose and fell over millions of years. Forests expanded during warmer periods and shrank during cooler periods. New habitats appeared while others disappeared. Mountain ranges rose as Earth's tectonic plates continued moving. Rivers changed direction. Seas advanced and retreated across the land. Mammals responded to each environmental change through migration, adaptation, or extinction. The movement of continents also influenced mammal evolution. As land masses slowly shifted into new positions, populations became separated by oceans, mountains, deserts, and rivers. Isolated populations evolved independently from one another. Over time, they became new species with unique characteristics suited to their local environments. South America remained isolated for a very long time. During this period, many unusual mammals evolved there. Some became large plant eaters, unlike those found elsewhere. Others became predators, filling hunting roles normally occupied by different groups on other continents. Isolation allowed many unique forms of life to develop without outside competition. Australia also remained separated from other major landmasses for millions of years. Marsupials became the dominant mammals across much of the continent. These mammals gave birth to very small young that continued developing inside a pouch. Kangaroos, koalas, wombats, and many other marsupials belong to this group. Their long isolation allowed them to evolve into many different forms suited for forests, grasslands, deserts, and mountains. Placental mammals became dominant across most other continents. In these mammals, babies developed inside the mother's body for a longer period before birth. This longer development often allowed newborns to be stronger and better prepared for life outside the womb. Placental mammals diversified into an enormous variety of forms, occupying almost every available habitat. Monotremes represented another branch of mammal evolution. These unusual mammals laid eggs instead of giving birth to live young. The platypus and echidnas survive today as living examples. Although few in number, they preserve ancient characteristics inherited from very early mammal ancestors. The spread of flowering plants greatly influenced mammal evolution. Flowers produced nectar that attracted insects, birds, and some mammals. Fruits provided rich food filled with energy. Seeds offered another valuable source of nutrition. Mammals that fed on fruits helped spread seeds by carrying them to new locations or passing them through their digestive systems. This interaction supported the spread of many plant species. Grasslands became much more widespread during later parts of the Cenozoic era. New kinds of grazing mammals evolved to feed mainly on grasses. Grass contains tiny hard particles that wear down teeth. In response, grazing mammals evolved taller teeth that continued functioning despite constant wear. Complex stomachs developed in several groups, allowing efficient digestion of tough plant material. The spread of open grasslands also encouraged faster movement. Predators and prey both benefited from speed. Longer legs, stronger muscles, and improved endurance became important adaptations. Herd behavior also appeared in many grazing species. Living together provided better protection because many eyes could watch for danger at the same time. Social behavior became increasingly important among many mammals. Living in groups offered several advantages. Adults could work together to protect young. Some species cooperated while searching for food. Others defended territories against rivals. Communication became more advanced through sounds, body movements, facial expressions, scents, and physical contact. Parental care remained one of the defining features of mammals. Mothers continued feeding babies with milk until they became strong enough to eat regular food. Many fathers also helped protect or raise young in certain species. Young mammals often spent extended periods learning important survival skills from older members of the group. This learning included finding food, recognizing danger, building shelters, hunting, avoiding predators, and interacting with others. Brains gradually became larger and more complex in many mammal groups. Better memory allowed animals to remember food sources, migration routes, and safe shelters. Improved learning abilities helped mammals adjust to changing environments. Problem-solving skills became increasingly valuable in habitats where food sources changed with the seasons. The senses of mammals also became highly developed. Many species relied heavily on smell. Sensitive noses detected food, predators, family members, and mates. Others depended mainly on hearing. Large ears captured distant sounds, while specialized inner ear structures improved balance. Vision became especially important for species active during daylight hours. Different reproductive strategies also supported mammal success. Some species produced many young within short periods. Others produced only a few offspring but invested large amounts of care into raising each one. The best strategy depended on environmental conditions, food availability, and risks from predators. Disease, parasites, drought, floods, volcanic eruptions, and changing climates continued affecting mammal populations throughout their history. Many species disappeared after failing to adapt. Extinction remained a natural part of evolution. At the same time, new species continued evolving from surviving populations. This constant pattern of extinction and evolution produced the rich diversity of mammals known today. Ice ages during the later Cenozoic era created additional challenges. Large ice sheets spread across northern regions during colder periods. Many mammals migrated toward warmer areas. Others adapted by growing thicker fur, storing more body fat, or changing their seasonal behavior. Some entered periods of reduced activity during winter to conserve energy. Large mammals became especially common during parts of the Ice Age. Woolly mammoths, mastodons, giant ground sloths, giant deer, woolly rhinoceroses, muskoxen, bison, cave bears, saber-toothed cats, and many other impressive mammals lived across different regions. Each species occupied its own habitat and depended on available plants or prey. Humans eventually appeared during the later stages of mammal evolution. Early members of the human family belonged to the primate group that had developed over millions of years from earlier tree-dwelling ancestors. Human evolution involved changes in walking, hand use, brain size, communication, and tool making. These developments occurred gradually across very long periods. As humans spread into different parts of the world, they encountered many large mammals. Some animals became important food sources. Others provided skins, bones, and other useful materials. Over time, humans also domesticated certain mammals, including dogs, sheep, goats, cattle, horses, pigs, and camels. Domestication changed both human societies and the animals themselves through selective breeding. Many mammal species today still carry features inherited from ancient ancestors that survived the extinction event at the end of the age of dinosaurs. Warm bodies, hair, milk production, advanced hearing, strong parental care, flexible diets, and adaptable behavior continue helping mammals survive in environments ranging from tropical rainforests and dry deserts to frozen polar regions, high mountains, open grasslands, underground tunnels, freshwater rivers, and the deepest parts of the oceans. Modern mammals include tiny shrews weighing only a few grams, enormous blue whales that are the largest animals known to have lived on Earth, intelligent elephants with strong social bonds, wolves that hunt in organized groups, bats filling the night skies, dolphins communicating through complex sounds, monkeys living in tropical forests, polar bears surviving in Arctic regions, and countless rodents, rabbits, antelopes, cats, dogs, and other species spread across nearly every part of the planet. After the event that ended the age of the dinosaurs, Earth was covered with dust, smoke, and tiny pieces of rock that had been thrown high into the atmosphere. These materials blocked much of the sunlight from reaching the ground. Days became darker and temperatures dropped across many parts of the planet. Plants struggled because they needed sunlight to make food. As many plants died, animals that depended on them also found it difficult to survive. Meat-eating animals then lost their food as plant-eating animals became fewer. This difficult period lasted for a long time before the atmosphere slowly became clearer. As the dust settled, sunlight returned little by little. Plants began growing again in places where they had survived. New leaves covered branches, fresh grasses appeared, and flowering plants spread across many regions. Seeds that had remained in the soil started growing once more. Forests slowly became greener, and rivers and lakes supported increasing numbers of living things. Life did not return exactly as it had been before because many kinds of animals and plants had disappeared forever. The survivors filled empty places in nature and slowly spread into new environments. The climate during this early period was generally warmer than the climate that many people know today. Large areas of the planet had warm temperatures throughout the year. Thick forests covered wide regions, even in places that are now much cooler. Rain fell often in many areas, helping trees and other plants grow in great numbers. The warm air held large amounts of moisture, leading to many wet environments where plants and animals could live. The oceans also changed after the disappearance of the dinosaurs. As the atmosphere slowly became cleaner, sunlight reached the sea again. Tiny living organisms near the surface began making food through sunlight. These tiny forms of life supported many other sea creatures. Fish populations slowly increased, and many marine animals found new places to live. Coral reefs also recovered in several parts of the world, creating homes for many kinds of sea life. Earth's climate continued changing because the continents never stopped moving. Deep below the surface, slow movement inside the planet pushed the great land masses in different directions. This movement changed the shapes of the oceans and affected the paths of ocean currents. Ocean currents carry warm water and cooler water around the planet. As these currents changed direction, they affected rainfall, temperatures, and weather in many places. Some regions became wetter, while others became drier over long periods. Volcanoes remained active in many parts of the world. When volcanoes erupted, they released ash, gases, and melted rock. Some of these gases entered the atmosphere. One important gas was carbon dioxide. Plants use carbon dioxide during growth, but large amounts of it in the atmosphere can help keep heat near Earth's surface. Over very long periods, volcanic activity added carbon dioxide to the atmosphere, helping influence the planet's climate. At the same time, natural processes also removed carbon dioxide from the atmosphere. Growing forests absorbed carbon dioxide as trees and other plants made food. Some carbon became trapped in dead plants that were buried beneath layers of soil over millions of years. Rain also helped remove some carbon dioxide by carrying it into rivers and oceans, where it became part of rocks forming on the sea floor. These natural processes helped shape Earth's climate over long periods. During the early part of this new age, mammals began spreading into many environments. Most mammals had been small during the time of the dinosaurs because they lived alongside many large predators. After the disappearance of the dinosaurs, many empty places became available. Mammals slowly grew into many different forms. Some stayed small while others became much larger. They spread into forests, grasslands, mountains, rivers, and even the oceans. The warm climate helped many mammals find food throughout much of the year. Fruits, leaves, seeds, insects, and other food sources were available in many regions. Different groups of mammals developed different ways of living. Some climbed trees, others lived underground. Some became skilled runners across open land. Others entered rivers and coastal waters. Birds also became more diverse during this period. Many bird groups survived the event that ended the age of the dinosaurs, because birds are closely related to certain small dinosaurs. With many large animals gone, birds spread into new environments. Different kinds of birds developed different beaks, wings, and feeding habits. Some became hunters, while others fed on seeds, fruits, insects, or fish. Flowering plants continued becoming more common across the planet. These plants worked closely with insects that carried pollen from one flower to another. Bees, butterflies, beetles, flies, and many other insects helped plants produce seeds. As flowering plants spread, they provided food for many animals, helping whole ecosystems become richer with life. The climate remained mostly warm for millions of years after the dinosaurs disappeared. In many regions, there were no large sheets of permanent ice at the poles. Sea levels were often higher because warmer conditions allowed ocean water to occupy more space. Coastal areas looked different from those of today, and some regions that are now dry land were covered by shallow seas. As millions of years passed, Earth's climate did not remain exactly the same. It slowly moved through warmer and cooler periods. These changes happened because many natural forces acted together. The movement of the continents continued, ocean currents changed, mountain ranges slowly rose higher, volcanoes released gases at different times. The amount of carbon dioxide in the atmosphere also changed over long periods. Each of these natural processes influenced temperatures and rainfall across the planet. Mountain building played an important part in changing climate. As tectonic plates pushed against each other, huge mountain ranges formed. High mountains affected the movement of winds. Moist air rose along mountain slopes, cooled and released rain or snow. The opposite side often became much drier. Mountains also trapped snow during colder seasons. This snow reflected sunlight and helped influence local temperatures. Rivers carried broken pieces of rock from the mountains toward the oceans. As rocks slowly broke apart through rain, wind, and changing temperatures, they removed small amounts of carbon dioxide from the atmosphere through natural chemical reactions. Over millions of years, this helped reduce greenhouse gases and slowly influenced Earth's climate. Around 56 million years ago, Earth experienced a period of unusually high temperatures. Scientists believe that very large amounts of carbon entered the atmosphere over a relatively short time in Earth's history. Temperatures rose across much of the planet. Warm conditions reached areas that are much cooler today. Many animals and plants adapted by moving into new regions where they could survive. Some species disappeared while others continued to spread into different environments. This warm period lasted for many thousands of years before temperatures slowly began falling again. Earth's natural systems gradually balanced the extra carbon through plant growth, rock weathering, and the movement of carbon into the oceans. These slow processes took a very long time. As the climate slowly cooled over millions of years, forests changed in many places. Some dense forests remained where rainfall stayed high. Other areas became more open as grasses spread across the land. Grasslands provided homes for new groups of animals that fed on grasses or hunted animals living there. The spread of grasses changed many ecosystems. Grasses could survive fires, dry seasons, and heavy grazing better than many other plants. Their roots reached deep into the soil, helping them grow again after damage. Animals gradually adapted to feeding on these plants, and many developed stronger teeth for eating tough grasses. Ocean circulation also continued changing as continents slowly moved. New openings between oceans formed while others closed. Water flowing around the planet changed direction. These changes affected temperatures in both the oceans and the atmosphere. Regions receiving warm ocean currents often became warmer and wetter, while areas influenced by cooler currents became cooler or drier. The southern continent of Antarctica slowly drifted into a position around the South Pole. As it became more isolated by surrounding ocean currents, temperatures there gradually fell. Snow remained on the land for longer periods. Over time, large ice sheets began forming. These growing ice sheets reflected more sunlight back into space, helping the region stay cold. The formation of permanent ice in Antarctica marked an important stage in Earth's changing climate. Large amounts of water became locked inside ice sheets, causing sea levels to fall in many places. New coastlines appeared as shallow seas became dry land. Animals and plants living near these changing coastlines had to adjust to the new conditions. Far to the north, climates also continued changing. Forests that had once reached very high northern regions slowly became smaller as temperatures dropped. Cold-loving plants spread into these areas. Animals living there gradually adapted to cooler conditions, thicker fur, seasonal changes, and longer periods of darkness during winter. As millions of years passed, the shape of the Earth slowly changed because the huge pieces of the planet's outer layer kept moving. These pieces, called tectonic plates, moved only a few centimeters each year, but over millions of years they carried entire continents into new positions. Oceans opened in some places and became smaller in others. Mountains rose where plates pushed against each other. Deep valleys formed where plates moved apart. These changes affected the movement of air and water across the planet. The oceans play a major part in controlling Earth's climate. Ocean water carries heat from warmer places toward cooler places. It also moves cold water into warmer areas. When the shapes of the oceans changed because of moving continents, the paths followed by these currents also changed. Some currents became stronger, while others became weaker or disappeared completely. This slowly changed the temperatures of many parts of the world. During this long period, the Atlantic Ocean became wider as North America and Europe slowly moved farther apart. At the same time, South America slowly moved closer to North America. Australia slowly drifted away from Antarctica. India moved north until it reached Asia. These slow movements changed both the land and the oceans. They also changed how air moved around the Earth. When India collided with Asia, the force of the collision pushed up enormous amounts of rock. Over millions of years, this formed the Himalayas and raised the high land known as the Tibetan Plateau. These high mountains changed the movement of winds across Asia. Air rising over the mountains lost much of its moisture as rain or snow before moving farther inland. The high mountains also affected temperatures because air becomes colder at higher elevations. Rain falling on these new mountains slowly wore away the rocks. Tiny pieces of rock and minerals were carried into rivers and eventually reached the oceans. During this process, carbon dioxide from the atmosphere became trapped in minerals. Since carbon dioxide helps keep heat in the atmosphere, removing some of it over millions of years slowly reduced the amount of heat that remained around the Earth. This change happened so slowly that it took millions of years before its effects became clear. Volcanoes also played an important part in Earth's climate. Volcanoes release gases into the atmosphere, including carbon dioxide. During some periods of Earth's history, volcanic activity released large amounts of this gas, helping to keep the planet warmer. During other periods, volcanic activity slowed, and less carbon dioxide entered the atmosphere. The balance between carbon dioxide entering the air and being removed by natural processes slowly changed over millions of years. Plants also helped shape Earth's climate. As forests spread across the land, they absorbed carbon dioxide during photosynthesis. Dead plants were sometimes buried before they could fully decay. Over very long periods, some of this buried plant material became coal or other fossil fuels. carbon that had once been in the atmosphere became locked inside the Earth. This also slowly reduced the amount of carbon dioxide in the air. The oceans absorbed large amounts of carbon dioxide as well. Tiny sea creatures used some of the dissolved carbon to build shells made from calcium carbonate. After these creatures died, many of their shells settled on the ocean floor. Layer after layer built up over millions of years, locking away even more carbon. This natural process happened continuously and slowly changed the atmosphere. The sun also changes over extremely long periods, but these changes happen so gradually that they cannot explain the beginning of the Ice Age by themselves. The amount of energy reaching Earth remained fairly steady while other changes inside Earth's climate system became more important. Scientists study the sun carefully because it influences weather and climate. But they also know that many different natural processes work together during Earth's long cooling. As Antarctica slowly became separated from the other southern continents, a wide stretch of ocean formed around it. This allowed a powerful ocean current to circle Antarctica without being blocked by land. The cold water stayed close to the continent and reduced the amount of warm water reaching its shores. As a result, Antarctica became much colder than before. Snow that fell there survived longer because less of it melted during warmer seasons. Year after year, fresh snow covered older snow. The weight of the upper layers slowly pressed the lower layers into solid ice. Over thousands of years, thick sheets of ice formed across Antarctica. As the ice became thicker, it reflected more sunlight back into space. Less heat was absorbed by the surface, helping the continent remain cold. The growth of ice in Antarctica marked an important step in Earth's cooling. The frozen continent stored huge amounts of fresh water inside its ice sheets. Sea levels slowly fell because so much water remained frozen on land. Coastlines slowly changed as the oceans became slightly lower. New areas of land appeared along some shores. The Arctic region followed a different path. Much of the Arctic is covered by ocean instead of land. Sea ice formed during cold seasons and melted during warmer seasons. As the climate slowly cooled, more sea ice survived from one year to the next. Larger areas stayed frozen for longer periods each year. The growth of sea ice affected the movement of ocean water. Salt was left behind when sea ice formed, making nearby ocean water heavier. This heavier water sank and helped drive deep ocean currents. These currents carried water across the world's oceans and affected temperatures in many distant places. The movement of air around the Earth also slowly changed. Cold air remained closer to the poles, while warmer air stayed nearer the equator. Winds carried moisture from the oceans toward the land. In colder climates, much of this moisture fell as snow instead of rain. If enough snow survived each summer, it slowly built up into larger ice fields. The Earth's path around the Sun also changes over very long periods. The shape of the orbit slowly changes. The angle of Earth's tilt slowly changes. The direction that the tilted Earth points also changes. These natural cycles affect how sunlight reaches different parts of the world during different seasons. Sometimes summers become slightly cooler in northern regions. When summers remain cool enough, winter snow melts more slowly, allowing ice sheets to grow. These orbital changes alone do not create an ice age. They work together with the amount of carbon dioxide in the atmosphere, the positions of the continents, the movement of ocean currents, and many other natural processes. When several of these conditions occur at the same time, long periods of cooling become more likely. As the Earth cooled, forests slowly changed. Some trees that needed warm weather disappeared from cooler regions. Other kinds of trees spread into areas where they could survive lower temperatures. Grasslands became larger in some places as forests became smaller. Different kinds of plants adapted to the changing climate in different ways. Animals also faced new challenges. Some moved toward warmer regions. Others remained where they were and slowly adapted over many generations. Thick fur became more common in animals living in colder places. Larger bodies helped some animals keep their body heat. Many animals changed their feeding habits as the plants around them changed. Birds adjusted their migration routes as temperatures shifted. Some traveled farther each year between breeding and feeding grounds. Others found new places to live all year. Fish also responded to changing ocean temperatures by moving into different waters. Entire groups of sea animals slowly changed where they lived. Freshwater systems changed as well. Rivers followed new paths when glaciers later reshaped the land. Lakes formed where ice blocked valleys or where melting glaciers left behind deep basins. Wetlands expanded in some regions and disappeared in others as rainfall patterns slowly changed. The atmosphere continued to change over millions of years. Levels of carbon dioxide remained lower than they had been during many earlier periods of Earth's history. Methane, another gas that helps keep heat in the atmosphere, also changed naturally over time. Small changes in these gases affected temperatures across the planet. Clouds also influenced Earth's climate. They reflected some sunlight back into space while also trapping some heat. The amount and type of cloud cover changed with temperatures, ocean conditions, and wind patterns. Scientists continue to study exactly how clouds affected Earth's long cooling, because this part of the climate system is very complex. Dust carried by the wind also played a role. Dry regions produced fine dust that traveled long distances through the atmosphere. Some dust settled on snow and ice, changing how much sunlight was reflected. Other dust reached the oceans where it supplied nutrients that supported tiny sea plants. These tiny plants absorbed carbon dioxide during their growth, adding another small influence to Earth's climate. The slow cooling continued over millions of years without following a perfectly steady path. There were warmer periods and cooler periods within this long trend. Natural events sometimes caused temperatures to rise for a while before cooling continued again. Even so, the overall direction remained toward a colder world that would eventually support vast ice sheets across large parts of the northern hemisphere. As each million years passed, the signs of cooling became easier to see in rocks, ice, ocean sediments, fossil plants, and fossil animals. These natural records preserved evidence of changing temperatures, changing rainfall, growing ice, and shifting ecosystems. Scientists study these records carefully because they provide detailed information about how Earth's climate changed over immense periods of time. The slow cooling became even more noticeable as millions of years continued to pass. The changes remained too small to notice during a single lifetime, yet they slowly reshaped the surface of the planet. Every generation of plants and animals lived under conditions that were only slightly different from those experienced by earlier generations. Over countless generations, those small changes added up and produced a very different Earth. Scientists know about these ancient climates by studying many kinds of natural records. Rocks formed at different times contain minerals that developed under certain temperatures. Layers of mud at the bottom of lakes and oceans preserve tiny remains of living things that existed when those layers were formed. Fossils show where different plants and animals once lived. Ice preserves bubbles of ancient air. Each source provides another piece of information about the climate of the distant past. Ocean sediments are especially valuable because they build up slowly over very long periods. tiny sea animals lived near the surface of the ocean. When they died, many of their shells sank to the bottom and became part of the growing layers of sediment. The chemical makeup of these shells changed depending on the temperature of the seawater in which the animals lived. By studying these shells, scientists can estimate how warm or cold the oceans were millions of years ago. The oceans store much more heat than the atmosphere. Because of this, changes in ocean temperatures often happen slowly. When the oceans gradually cooled, they affected the air above them. Cooler oceans produced cooler winds in many regions. These winds carried their influence far inland, changing rainfall, snowfall, and seasonal temperatures across large areas. Sea ice became more common in northern waters as cooling continued. During winter, ice spread across larger parts of the Arctic Ocean. During summer, less of that ice melted away. This left more bright ice covering the sea throughout the year. Since ice reflects much of the sunlight that reaches it, areas covered by ice absorbed less heat. This helped keep the surrounding air and water colder. Snow also became more likely to remain on high mountains. Mountains receive lower temperatures because of their elevation. As the climate cooled, snow that once melted during summer survived for longer periods. Small patches of snow slowly became larger fields of permanent ice. Over thousands of years, these fields of ice slowly moved downhill under their own weight, forming glaciers. Glaciers are rivers of ice that move very slowly. They may appear still, but they are constantly moving. Ice near the top receives fresh snowfall every year. The weight of new snow presses down on older snow beneath it. Over time, the lower layers become dense ice. Gravity slowly pulls this heavy ice downhill. The movement is usually very slow, often only a short distance each year. As glaciers advanced, they changed the land beneath them. Rocks trapped inside the moving ice scraped against the ground. Loose soil was carried away. Valleys became deeper and wider. Large rocks were pushed across the landscape and left far from where they had originally formed. These changes happened gradually as glaciers continued their slow movement. Rivers were also affected by cooling temperatures. Some rivers received more water during warmer seasons when mountain ice partially melted. Others became smaller because more water remained frozen throughout the year. The amount of sediment carried by rivers also changed. As glaciers ground rocks into fine pieces, rivers transported this material towards the oceans. Rainfall patterns slowly shifted across the continents. Some regions became wetter because changing winds carried more moisture toward them. Other regions became drier because weather systems followed different paths. Forests, grasslands, wetlands, and deserts all changed in size as rainfall slowly increased or decreased. The cooling climate affected the soil as well. In colder conditions, dead leaves and other plant material broke down more slowly. This changed the way nutrients returned to the soil. Plants had to adapt to shorter growing seasons in cooler regions. Some plants completed their life cycles more quickly. Others entered periods of rest during cold weather before beginning to grow again when temperatures increased. Many kinds of insects also changed their ranges. Some moved into warmer areas where food remained available throughout the year. Others adapted to survive freezing temperatures by producing natural chemicals inside their bodies that reduced damage caused by ice. These changes happened through many generations as populations slowly adjusted to their surroundings. Large mammals that appeared during this period faced changing environments. Some early mammals had already become much larger than their distant ancestors. As forests became less widespread in certain regions, open grasslands expanded. Animals that fed on grasses became more common in these areas. Their teeth slowly evolved to handle tougher plant material that contained tiny grains of silica. Predators also changed as the animals they hunted changed. Faster prey encouraged the development of predators that could run over long distances. Strong senses of smell, hearing, and sight became important for finding food across open landscapes. These gradual changes happened over millions of years through natural selection. Birds continued to spread into many different habitats. Some specialized in living near lakes and rivers. Others adapted to grasslands, forests, mountains, or coastlines. As climates shifted, many bird populations changed their migration routes to match the changing seasons and available food. Life in the oceans changed alongside life on land. Cold water contains more dissolved oxygen than warm water. As some ocean regions cooled, different kinds of marine animals became more successful there. Fish, shellfish, and marine mammals slowly adjusted to changing temperatures and changing food supplies. Tiny floating plants known as phytoplankton remained important because they formed the base of many ocean food chains. Their growth depended on sunlight and nutrients brought to the surface by ocean currents. Changes in currents affected where these nutrients became available. This influenced the distribution of many forms of marine life. The deep ocean also experienced gradual changes. Cold, dense water formed near the poles and slowly sank towards the ocean floor. From there it moved through the deep oceans before eventually rising again in other regions. This worldwide circulation helped distribute heat, oxygen, and nutrients throughout the oceans. As Earth's climate cooled, this circulation also changed. The atmosphere and oceans constantly exchanged heat and moisture. Warm water increased evaporation. Cooler water reduced it. The amount of water vapor in the atmosphere changed as temperatures changed. Since water vapor is also a greenhouse gas, these natural changes influenced Earth's climate in many ways. Large storms continued to develop over the oceans just as they do today. Their paths depended on ocean temperatures, wind patterns, and atmospheric conditions. As cooling continued, some storm tracks gradually shifted. This changed where heavy rainfall occurred and where dry conditions became more common. The changing climate also affected wildfire patterns. In some regions, cooler and wetter conditions reduced the spread of fires. In other places, seasonal dryness continued to allow fires to occur naturally after lightning strikes. Fire remained an important part of many ecosystems, helping shape forests and grasslands over long periods. The amount of sunlight reaching Earth changed slightly because of natural variations in Earth's orbit. Sometimes northern summers received a little less sunlight. During those times, winter snow was less likely to melt completely before the next winter arrived. Layer after layer of snow slowly built up into thicker ice sheets. These orbital cycles repeated over tens of thousands of years. Sometimes they supported cooling, while at other times they supported warming. Their effects depended greatly on the existing climate. Since the Earth had already become cooler because of many long-term changes, these cycles became increasingly important in determining when glaciers expanded or retreated. As cooling spread across higher northern latitudes, frozen ground became more widespread. In many places, the soil remained frozen throughout the entire year below the surface. Today, this permanently frozen ground is known as permafrost. Plants growing in these regions developed shallow root systems because deeper soil remained frozen. Animals living in cold regions adapted in many different ways. Some grew thick coats of fur before winter arrived. Others stored fat beneath their skin. Many migrated to warmer places during the coldest seasons. Some entered long periods of reduced activity while living on stored body fat until warmer weather returned. Plant communities also shifted gradually. Evergreen trees spread across some cooler regions, because they could continue growing whenever conditions became suitable. Deciduous trees survived by dropping their leaves before winter. Grasses expanded across open plains where trees could no longer grow easily. The spread of grasslands influenced many animal groups. Herds of grazing mammals became larger in suitable regions. Their movement helped spread plant seeds and affected the growth of vegetation. Predators followed these herds, creating changing patterns of life across broad landscapes. Freshwater lakes recorded these environmental changes. Layers of mud collected on their bottoms year after year. Pollen from nearby plants settled into these layers. By examining ancient pollen grains, scientists can identify which kinds of plants lived near a lake during different periods. This allows them to reconstruct ancient climates with remarkable detail. Tree rings also provide information for more recent parts of Earth's history. Each year, most trees produce a new growth ring. Wide rings often indicate favorable growing conditions, while narrow rings may indicate colder or drier years. Although tree rings do not reach back millions of years, they help scientists understand more recent climate changes and improve their understanding of natural climate patterns. Chemical studies of ancient rocks continue to improve. Modern laboratory equipment allows scientists to measure extremely small differences in the elements found inside rocks, fossils, and minerals. These measurements reveal information about ancient temperatures, rainfall, ocean chemistry, and atmospheric conditions. New discoveries continue to add to what is known about Earth's long cooling. By about 34 million years ago, Antarctica had become covered by extensive ice sheets that remained throughout the year. This marked an important stage in the planet's cooling history. Millions of years later, further cooling continued, especially during the late part of the Neogene period. Conditions slowly developed that would eventually allow enormous ice sheets to spread across much of North America, Europe, and Asia during the Ice Age. This is the second part. The cooling that continued after Antarctica became covered with thick ice did not stop. It remained a slow process that stretched across millions of years. The planet still experienced warmer times and cooler times, but the general pattern continued toward lower average temperatures. These changes affected every part of the Earth, from the highest mountains to the deepest oceans. Around the world, mountain ranges continued to rise as tectonic plates kept moving. New rocks were lifted above sea level while older mountains were slowly worn down by rain, rivers, wind, snow, and ice. The wearing away of these rocks continued to remove small amounts of carbon dioxide from the atmosphere through natural chemical reactions. Although each year brought only a tiny change, millions of years allowed this process to have a lasting effect. The continents continued their slow movement. North America and South America gradually became connected by a narrow strip of land. This event changed the paths of both ocean currents and migrating animals. Warm water that had once flowed freely between the Atlantic Ocean and the Pacific Ocean was forced to take different routes. More warm water traveled toward the North Atlantic. As this water released heat into the atmosphere and later cooled, it became heavier and sank into the deep ocean. This helped strengthen global ocean circulation. The stronger movement of ocean water increased the amount of moisture carried into northern regions. During winter, much of this moisture fell as snow. If summers remained cool enough, not all of the snow melted before the next winter arrived. New snowfall covered the older layers, slowly building thicker fields of snow that eventually became solid ice. This slow build-up of ice did not happen everywhere at the same time. Some mountain ranges developed glaciers long before nearby lowlands did. High elevations stayed colder throughout the year, making them suitable places for snow to survive. These mountain glaciers slowly expanded into nearby valleys and continued shaping the landscape. The northern parts of North America, Europe and Asia gradually became colder than they had been during earlier periods. Winter seasons grew longer in many places. Summer warmth became less effective at melting the snow left behind by winter. This allowed permanent ice to spread farther across the land. As ice sheets slowly became larger, they stored enormous amounts of fresh water. Because so much water remained frozen on land, sea levels slowly dropped. Areas that are now covered by shallow seas became dry land. Rivers extended farther across these newly exposed coastal plains before reaching the oceans. Some land bridges appeared because of the lower sea level. These land connections allowed animals to move between continents. Many species gradually spread into new regions where they found food and suitable habitats. Over thousands of generations, some populations became separated from others and slowly developed different characteristics through evolution. Large grazing mammals expanded across wide grasslands. These open landscapes supported many kinds of plant-eating animals. Some developed long legs for traveling across great distances. Others grew powerful teeth for feeding on tough grasses. Their digestive systems also adapted to make better use of the food available in cooler environments. Large meat-eating mammals followed these herds. Their survival depended on finding enough prey. Some hunted alone, while others lived and hunted in groups. Different hunting methods appeared as animals adapted to different environments and different kinds of prey. Small mammals also became successful during this time. Rodents, rabbits, insect eaters, and many other groups spread into forests, grasslands, mountains, and cold northern regions. Their short generations allowed populations to adapt more quickly to changing conditions over long periods. Primates also continued to evolve. Different branches developed in Africa, Asia, and other regions. Changing forests and expanding grasslands influenced where these animals lived. Some continued living mainly in trees, while others spent increasing amounts of time on the ground. These gradual environmental changes formed part of the long history that eventually led to the appearance of early human ancestors. Plant life continued responding to cooling temperatures. Evergreen forests became common across many northern regions. Grasses expanded across broad plains. Cold-resistant shrubs spread into areas where trees could no longer survive. Mosses and lichens covered rocky ground in colder climates. Every plant community adjusted according to the amount of sunlight, rainfall, temperature, and length of the growing season. The soil itself changed as climates became colder. Frozen ground limited how deeply water could move into the earth. In many places, repeated freezing and thawing slowly broke rocks into smaller pieces. This process created new soils, while also changing the shape of hills and valleys over long periods. Wind became an important force in cold, dry regions. Fine dust left behind by glaciers was carried over long distances. Some of this dust settled on grasslands and added minerals to the soil. These minerals supported the growth of many plants. Other dust settled into lakes and oceans where it became part of the natural record. Preserved in sediments. The cooling climate influenced rainfall across different parts of the world. Some tropical regions remained warm but became either wetter or drier, depending on changing wind patterns. Monsoon systems changed as mountain ranges and ocean temperatures influenced the movement of moist air. These gradual changes affected rivers, forests, wetlands, and the people and animals that would later depend on them. The Pacific Ocean, the Atlantic Ocean, the Indian Ocean, and the Southern Ocean all continued exchanging heat through powerful currents. These currents remained one of the main ways that heat moved around the planet. Even small changes in their paths affected weather over very large areas. Scientists continue studying these currents because they remain important for understanding both ancient and modern climates. The atmosphere also contained tiny particles from volcanic eruptions, sea salt carried by waves, dust lifted by wind, pollen released by plants, and smoke from natural fires. These particles sometimes reflected sunlight and sometimes helped clouds form. Their effects depended on where they were found and how long they remained in the atmosphere. Earth's magnetic field continued protecting much of the atmosphere from charged particles arriving from space. While this magnetic field changed naturally over time, it remained an important part of the planet's ability to support life. The atmosphere, oceans, land, and living things all interacted continuously as the climate slowly evolved. The long cooling trend eventually reached a stage where large ice sheets repeatedly expanded and later partly melted, in response to changes in Earth's orbit around the Sun. During colder phases, glaciers advanced across northern lands. During warmer phases, many glaciers retreated. These repeating cycles became one of the defining features of the Ice Age. Each advance of ice reshaped the land. Valleys became smoother and wider, hills were worn down, lakes formed where glaciers carved deep basins or where melting ice blocked natural drainage. Rivers adjusted to these changing landscapes by finding new paths toward the sea. Many animals adapted successfully to these colder environments. Woolly mammoths developed thick coats of hair and large stores of fat beneath their skin. Woolly rhinoceroses also possessed heavy fur that helped them survive in cold grasslands. Musk oxen, reindeer, and several other animals thrived across northern regions where grasses, mosses, and small shrubs remained available. Other animals could not adapt quickly enough. Some disappeared from regions that became too cold. Others moved toward warmer areas closer to the equator. Plant communities shifted in the same way, slowly following the climates that best supported their growth. Bird migration became even more important. Many species traveled thousands of kilometers between breeding grounds and winter feeding areas. These seasonal journeys helped birds survive changing temperatures while taking advantage of food supplies available during different times of the year. Marine mammals also adjusted to colder oceans. Seals, whales, walruses, and other species expanded into icy waters where food remained plentiful. Thick layers of fat beneath their skin helped them stay warm while swimming in very cold seas. Fish populations shifted as ocean temperatures changed. Some species spread into colder waters, while others remained closer to warmer regions. These movements influenced the feeding habits of seabirds, marine mammals, and people much later in history. As the Ice Age developed, enormous amounts of water remained locked inside glaciers and continental ice sheets. This continued to keep sea levels lower than during warmer periods. Coastlines changed repeatedly as ice expanded and retreated over thousands of years. Scientists continue studying every stage of this long cooling because it explains many features of the modern world. The Great Lakes of North America, many valleys across Europe, countless lakes in Canada and Scandinavia, and many other landscapes still show the marks left behind by ancient glaciers. Layers of sediment preserved beneath lakes, oceans, and ice sheets continue providing new information about ancient climates, allowing researchers to improve their understanding of how Earth's climate slowly changed over millions of years and how those gradual natural processes eventually led to the long Ice Age that shaped much of the planet's surface before the appearance of human civilizations across many regions of the world. The formation of the first great ice sheets began during a time when Earth was slowly changing, in ways that affected every part of the planet. These changes did not happen over a few years or even over many human lifetimes. They happened over millions of years as the land, the oceans, the air, and the movement of the planet continued to change. The first great ice sheets did not appear suddenly. They formed little by little as temperatures dropped and winter snow stayed on the ground for longer periods. Over time, the snow became thicker, heavier, and harder until it slowly turned into solid ice. As this process continued year after year, the ice spread across large areas of land and became the huge ice sheets that later shaped much of Earth's surface. For a very long time before these great ice sheets formed, much of the planet was warmer than it is today. Large forests covered many parts of the continents, even in places that are now cold. Many different kinds of animals and plants lived in these warm regions. Rain fell often, rivers flowed across wide plains, and many lakes filled low areas of the land. The oceans also remained warm, helping to keep temperatures higher across much of the world. Life continued to grow and spread because the climate supported many different living things. The slow cooling of Earth began because many natural changes happened at the same time. One important reason was the steady movement of the continents. The large pieces of Earth's outer layer never stay in one place forever. They move very slowly across the surface of the planet. Although this movement is too slow for people to notice during their lives, it changes the position of the continents over millions of years. As the continents moved, they changed the way ocean water flowed around the world. They also changed the direction of winds that carried heat and moisture through the atmosphere. Ocean currents play a very important part in controlling Earth's climate. Warm water carries heat from places near the equator toward colder parts of the world. Cold water moves back toward warmer regions. This steady movement helps spread heat around the planet. When the positions of the continents changed, many ocean currents also changed. Some warm currents became weaker or moved in different directions. Some cold currents reached places they had not reached before. These changes slowly reduced temperatures in many regions. The atmosphere also changed over long periods. Carbon dioxide is one of the gases that helps trap heat near Earth's surface. When the amount of carbon dioxide slowly became lower, less heat remained in the atmosphere. Earth gradually became cooler. This change did not happen in a short time. It happened over millions of years as natural processes removed carbon dioxide from the air. Rocks slowly broke down through weathering. Rivers carried minerals into the oceans. Tiny sea animals used carbon to build their shells. When these animals died, many of their shells settled on the ocean floor, where the carbon remained trapped for very long periods. Volcanic activity also affected the amount of carbon dioxide in the atmosphere. Volcanoes release gases from deep inside Earth. During some periods, volcanic activity added large amounts of carbon dioxide to the air. During other periods, the amount released was lower. Over millions of years, the balance between carbon entering and leaving the atmosphere changed many times. When less carbon dioxide remained in the air, Earth slowly lost some of its warmth. The position of Earth in space also played a part. The planet travels around the Sun every year, but the shape of its path changes very slowly over long periods. The angle at which Earth tilts also changes little by little. In addition, the direction in which Earth's axis points slowly changes over thousands of years. These slow changes affect how much sunlight reaches different parts of the planet during different seasons. At certain times, summers in high northern and southern regions became cooler. Cooler summers meant that snow from the previous winter did not melt completely. Snow that survives one summer has a greater chance of surviving the next one. Each new winter adds another layer of snow on top of the older snow. As more layers collect, the weight of the upper snow presses down on the lower layers. The tiny spaces filled with air become smaller. The snow becomes harder and denser. Over many years, it changes into a form called firn. As even more snow builds up, the firn slowly changes into solid glacier ice. This process takes a long time because each layer must be pressed under the growing weight of fresh snow. The first great ice sheets began in places where winters were already cold enough for heavy snowfall, and where summers were cool enough to leave part of that snow behind. High mountains helped this process because temperatures become lower at higher elevations. Snow often remained on mountain peaks throughout the year. These areas became places where glaciers first started to grow. As the glaciers became larger, they slowly moved downhill under their own weight. Glaciers move very slowly. The ice may seem completely still, but it is always moving little by little. The great weight of thick ice causes it to spread outward. Ice near the center pushes against ice closer to the edges. The bottom of the glacier also moves as pressure builds beneath it. This movement may be only a short distance each year, but over thousands of years it allows glaciers to travel across valleys and plains. As glaciers moved, they picked up loose rocks, sand and soil from the ground beneath them. Some rocks became trapped inside the ice. Others were pushed forward by the moving glacier. The great weight of the ice pressed down on the land below. Soft ground became flattened, while harder rock surfaces were slowly worn away. Deep scratches formed on exposed rocks as pieces of stone trapped in the moving ice scraped across them. The first great ice sheets continued to grow because snowfall remained greater than melting in many places. Every winter added fresh snow. Every cool summer allowed much of that snow to remain. Over thousands of years, the growing layers produced ice that became hundreds and later thousands of feet thick. The ice spread farther away from the places where it first formed. Large parts of the land slowly disappeared beneath solid sheets of ice. As the ice expanded, it reflected a large amount of sunlight back into space. Ice has a bright surface that does not absorb much heat. This helped keep temperatures lower in regions covered by snow and ice. Cooler conditions allowed even more snow to survive through the summer months. The growing ice sheets continued to spread across wide areas because the climate remained cold enough to support their growth. The oceans also responded to the growing ice sheets. Huge amounts of water that had once been part of the oceans became locked inside glaciers and ice sheets. As more water froze on land, the level of the oceans slowly fell. Coastlines moved farther away from many areas. New stretches of land appeared where shallow seas had once covered the ground. Rivers flowed across these newly exposed areas before reaching the sea. Many islands became connected to nearby continents as sea levels dropped. These land connections allowed animals to move into places that had once been separated by water. Over many generations, different kinds of mammals spread into new regions while searching for food and suitable places to live. Some later became isolated again when the ice melted and sea levels rose during warmer periods. The growing ice sheets changed the flow of rivers. Some rivers became blocked by walls of ice. Water collected behind these frozen barriers and formed large lakes. Other rivers found new paths around the edges of glaciers. As the glaciers continued moving, they changed the shape of valleys and hills. Meltwater from the edges of the ice carried sand, gravel and fine soil across wide areas. These materials settled in different places as the water slowed. The air above the growing ice sheets became colder because of the large frozen surface below. cold air spread into nearby regions during the winter months. Storm paths slowly changed as differences in temperature affected the movement of air across the planet. Some places became wetter because storms carried more snow. Other regions became drier because changing wind patterns reduced rainfall. The first great ice sheets did not grow at exactly the same time everywhere on Earth. Different regions cooled at different rates depending on their location, the height of the land, nearby ocean currents, and local weather patterns. Some mountain glaciers expanded long before large ice sheets covered nearby plains. In other places, thick snowfall continued for thousands of years before enough ice accumulated to form wide sheets that spread across entire regions. The southern continent became especially important in the history of Earth's cooling. As it slowly moved closer to the South Pole over millions of years, conditions became favorable for year-round ice. Snowfall remained on the land through the summer, allowing thick layers of ice to build steadily. Once large ice sheets became established there, they continued growing because the cold conditions supported their survival. Around the edges of the great ice sheets, the land became much more suitable for plants and animals. These regions experienced short summers and long, cold winters. The snow melted during the warmer months, allowing plants to grow before winter returned. Farther away from the great ice sheets, many lands remained free from permanent ice. Grasslands stretched across large parts of Europe, Asia, and North America. These open lands became home to many animals that fed on grasses, small plants, leaves, and shrubs. Other areas contained forests where trees continued to grow, although the kinds of trees depended on the local climate. Some forests had evergreen trees that kept their leaves throughout the year, while other forests contained trees that lost their leaves before winter arrived. Wetlands, rivers, lakes, and coastal regions also provided important homes for countless living creatures. One of the most common plant communities during the Ice Age was the tundra. Tundra developed in cold places, where the ground stayed frozen beneath the surface for most of the year. Only the top layer softened during the short summer. Because roots could not grow very deeply into the frozen ground, tall trees were mostly absent from these regions. Instead, the land supported low-growing plants that stayed close to the surface. Mosses covered many damp areas and held water after the snow melted. Lichens spread across rocks and soil, surviving in places where few other plants could grow. Small flowering plants appeared during the short summer, producing seeds before the cold returned. Tiny shrubs remained close to the ground, where they received some protection from strong winds. Grasses played an important part in many Ice Age environments. They grew quickly during the warmer months and covered wide areas of open land. Their roots helped hold the soil together, reducing the amount of loose earth carried away by wind and water. Grasslands supported large groups of plant-eating animals that depended on fresh growth each year. Different kinds of grasses appeared in different regions according to the amount of rain and the local temperatures. Some grasses remained short, while others reached greater heights where growing conditions were better. Small shrubs were also common across much of the Ice Age landscape. Many shrubs produced leaves, flowers, berries, or seeds that served as food for birds and mammals. Some developed thick stems and small leaves that reduced water loss during cold and windy weather. Others spread close to the ground, avoiding damage from strong winter storms. Their roots helped them survive repeated freezing and thawing as the seasons changed. Mosses were among the most successful plants during the Ice Age. These simple plants did not need deep roots and could grow on rocks, damp soil, and fallen wood. They absorbed water directly through their surfaces and became active whenever enough moisture was available. Mosses helped keep the ground moist after snow melted and provided shelter for tiny insects and other small creatures. Their presence also helped begin the slow formation of soil in places where bare rock had been exposed by moving glaciers. Lichens were another important part of Ice Age plant life. A lichen is formed through the close relationship between a fungus and tiny cells that produce food from sunlight. This partnership allowed lichens to survive in cold places where many other plants could not live. They grew very slowly but remained alive for many years. Reindeer and caribou depended heavily on lichens during winter, when fresh grasses and leaves became difficult to find. By feeding on lichens beneath the snow, these animals survived long seasons of cold weather. Flowering plants also appeared during the brief summers. They had only a short time to grow, produce flowers, attract insects and form seeds before freezing temperatures returned. Many developed bright flowers that attracted bees, flies, and other insects. The seeds of these plants spread through the wind, water, or by attaching themselves to animals. Some seeds remained in the soil throughout the winter and began growing when warmer weather returned. In regions that experienced slightly warmer conditions, forests continued to exist. Evergreen trees such as pine, spruce, and fir covered large areas. Their narrow leaves reduced water loss during winter, allowing them to survive cold weather. Snow often slid from their branches instead of collecting in heavy amounts that could break them. These forests sheltered many birds, small mammals, and larger animals seeking protection from strong winds. Deciduous trees also survived in places where summers lasted longer. Oak, birch, willow, and other trees grew near rivers and lakes or in regions with enough rainfall. These trees dropped their leaves before winter, reducing damage caused by freezing temperatures. Their fallen leaves slowly became part of the soil, adding nutrients that supported future plant growth. Rivers and lakes remained important centers of life throughout the Ice Age. Water plants grew along their edges, providing food and shelter for fish, insects, amphibians, and birds. Reeds and other tall plants lined many shallow waters. Fish continued to live beneath the ice during winter, becoming more active after the spring thaw. Birds gathered around these waters to feed, rest, and raise their young during the warmer months. The Ice Age supported many kinds of insects. Although cold weather limited their activity for much of the year, insects became numerous during the short summers. Bees collected pollen from flowers while helping plants reproduce. Butterflies searched for nectar. Beetles lived beneath leaves, inside dead wood, and in the soil. Flies, mosquitoes, and many other insects appeared wherever water collected after snow melted. These insects became food for birds, fish, frogs, and many small mammals. Spiders also lived in Ice Age environments. They hunted insects among grasses, shrubs, and forest floors. Their numbers depended on the availability of insect prey. Many survived the winter by remaining inactive in protected places until warmer weather returned. Fish continued to thrive in rivers, lakes, and coastal waters. Cold water species became especially successful because they were well suited to lower temperatures. Salmon migrated between rivers and the sea in regions where such journeys remained possible. Trout lived in clear streams fed by melting snow and glaciers. Many smaller fish formed an important part of the food supply for birds, mammals, and larger fish. Amphibians survived where conditions allowed. Frogs and salamanders remained active during the warmer months and spent winter hidden beneath mud, fallen leaves, or other protected places. Their breeding seasons depended on the arrival of spring, when pools and wetlands filled with fresh water from melting snow. Reptiles became less common in the coldest parts of the world, because they depend heavily on warmth from their surroundings. However, some snakes, turtles and lizards continued living in regions where temperatures stayed mild enough during the warmer months. They spent long periods inactive during winter until the return of warmer weather. Birds filled the skies throughout the Ice Age. Many species migrated between warmer and colder regions as these seasons changed. Others remained throughout the year, relying on thick feathers and stored food to survive winter. Birds nested in forests, grasslands, cliffs, wetlands and along coastlines. Some fed on seeds, others hunted insects, fish or small mammals. Birds of prey searched the open landscape for rabbits, rodents and other animals. Water birds gathered around lakes and rivers where food remained available. Small mammals formed the foundation of many food chains. Mice, voles, lemmings, squirrels, rabbits and hares reproduced quickly and served as food for larger hunters. Many built underground tunnels that protected them from freezing temperatures and predators. Some stored seeds and plant material before winter, while others remained active beneath the snow where temperatures were slightly less severe than above the surface. Lemmings became especially important in northern tundra regions. Their populations sometimes increased greatly when food was plentiful. During these times, many predators such as foxes, owls and weasels found abundant food. When lemming numbers later declined, these hunters often faced more difficult conditions until populations recovered again. Beavers lived along rivers and streams where trees provided building materials and food. They cut branches, gathered leaves, and built shelters that offered protection from predators and cold weather. Their activities changed the movement of water, creating ponds that supported many other forms of life, including fish, insects, birds, and amphibians. Large plant-eating mammals became some of the best-known animals of the Ice Age. Mammoths walked across wide grasslands in family groups. Their long hair and thick layer of body fat helped them survive cold temperatures. Their curved tusks allowed them to move snow aside while searching for grasses and other plants hidden beneath. Mammoths spent much of their time feeding because their large bodies required great amounts of food every day. Woolly rhinoceroses also lived across many northern grasslands. Like mammoths, they possessed thick hair that protected them from the cold. They fed mainly on grasses and low-growing plants. Their strong bodies and large horns helped them clear snow and defend themselves when necessary. These animals traveled across open landscapes where food remained available throughout the changing seasons. Large herds of bison grazed across extensive grasslands. Their thick coats protected them during winter, while their powerful bodies allowed them to travel long distances in search of fresh grazing areas. Horses also lived in many open regions, feeding on grasses and moving in groups that provided some protection against hunting animals. Deer also lived across many Ice Age environments. Different kinds of deer occupied forests, open grasslands, and areas near rivers. They fed on grasses, leaves, young branches, shrubs, and other plants that changed with the seasons. Many species developed thick winter coats that helped them stay warm during long periods of cold weather. As spring arrived, these coats became lighter, making it easier for the animals to move during the warmer months. Male deer in many species grew antlers that were used during the breeding season. After this period ended, the antlers fell off and later grew back. Deer traveled in groups for much of the year, although some lived alone or in smaller family units, depending on the species and the local environment. Reindeer became one of the most successful large mammals of the Ice Age. They spread across wide northern regions where tundra plants were common. Their broad hooves helped them walk across snow, muddy ground and soft soil. During winter they used their hooves to scrape away snow so they could reach lichens, grasses and small plants underneath. Their thick fur trapped warm air close to the body, helping them survive very low temperatures. Large herds moved over long distances as the seasons changed, following fresh plant growth and avoiding areas where food became scarce. Musk oxen also lived in cold northern lands. These animals had very long outer hair that covered a soft layer of warm wool beneath. This thick covering reduced the loss of body heat during freezing weather. Musk oxen usually stayed together in groups. When danger approached, the adults often gathered closely with the younger animals, protected in the center. They fed mainly on grasses, sedges, mosses and small shrubs that remained available throughout much of the year. Wild sheep and wild goats occupied rocky hills and mountain slopes where they fed on grasses and low plants. Their strong legs allowed them to move across rough ground with confidence. Thick coats protected them during winter, while their sharp senses helped them detect danger from hunting animals. They often lived in groups, giving them a better chance of noticing approaching predators. Many kinds of rodents continued to thrive during the Ice Age. Ground squirrels dug deep burrows that protected them from severe weather. Some species entered long periods of reduced activity during the coldest part of the year, living on stored body fat until temperatures became warmer. Other rodents stayed active beneath the snow, feeding on roots, seeds and plant stems that remained available throughout winter. Hares were well suited to snowy environments. Some species developed white fur during winter, helping them remain less noticeable against snow-covered ground. When spring arrived, their fur changed color again as the landscape became greener or browner. Their powerful back legs allowed them to escape quickly from danger. Hares fed on grasses during summer and switched to twigs, bark and small branches during winter, when fresh plants were unavailable. Foxes lived across many Ice Age habitats. Arctic foxes occupied the coldest northern regions. Their thick fur changed color with the seasons in many areas, providing protection throughout the year. They hunted small mammals, birds, eggs, insects, and sometimes fed on animals that had already died. Red foxes occupied somewhat warmer regions and showed similar flexibility in finding food. Their ability to eat many different kinds of food helped them survive changing conditions. Wolves became important hunters across large parts of the Ice Age world. They usually hunted in groups, allowing them to capture animals much larger than themselves. Their prey included deer, horses, young mammoths, bison, and many smaller animals depending on what was available. Wolves traveled long distances while searching for food. Strong family bonds within the group helped them raise young and defend their territory. Large cats also lived during the Ice Age. Among the best known were the saber-toothed cats. These animals possessed long upper canine teeth that have been found in many fossil discoveries. They hunted large plant-eating animals living in grasslands and open woodlands. Scientists continue to study exactly how these cats used their long teeth, but it is clear that they were skilled hunters adapted to the environments in which they lived. Other large cats, similar to modern lions, also occupied parts of Europe, Asia, and North America. They hunted deer, horses, bison, and other large mammals. Their success depended on healthy populations of plant-eating animals. As climates changed and prey numbers shifted, the distribution of these hunting cats also changed. Brown bears lived across many forests and open landscapes. They ate a wide variety of foods, including berries, roots, fish, insects, honey, and meat. This varied diet allowed them to survive in many different environments. During the coldest months, many bears entered periods of winter sleep inside sheltered dens. While inactive, they lived on fat stored during the warmer seasons. cave bears occupied parts of Europe during much of the Ice Age. Fossils show that these bears were very large animals. Evidence suggests that plants formed an important part of their diet, although they may also have eaten other foods depending on local conditions. They often used caves for shelter, especially during winter. Hyenas lived in some Ice Age regions, particularly in parts of Europe and Asia. They hunted living animals and also fed on animals that had already died. Their strong jaws allowed them to crush bones and obtain nutrients that many other animals could not reach. Fossils found in caves show that hyenas sometimes carried bones back to their shelters. Wolverines occupied northern forests and tundra. These powerful mammals fed on small animals, birds, eggs, insects, and the remains of larger animals. Thick fur protected them from severe cold. They travelled over large areas while searching for food and were capable of surviving in harsh environments. Weasels, martens, and otters also lived during the Ice Age. Weasels hunted rodents inside tunnels beneath the snow. Martens searched forests for birds, small mammals, insects, and fruit. Otters remained closely connected to rivers and lakes, feeding mainly on fish while using their thick waterproof fur to stay warm in cold water. Many species of birds remained active throughout the changing seasons. Snowy owls hunted across open tundra where they searched for lemmings and other small mammals. Eagles flew over mountains and grasslands looking for prey. Hawks hunted birds and rodents in forests and open country. Ravens adapted well to different environments by eating many kinds of food, including seeds, insects, eggs, and animal remains. Water birds gathered around rivers, lakes, and wetlands. Ducks, geese, swans, cranes, and many other birds nested in these areas during the warmer months. Some migrated to warmer lands before winter arrived, while others stayed wherever open water remained available. Wetlands supported large numbers of insects, fish, frogs, and aquatic plants that provided rich feeding grounds. The seas surrounding the Ice Age continents also supported abundant life. Cold ocean waters contained many kinds of fish, shellfish, and tiny drifting organisms that formed the base of marine food chains. Seals rested along icy shores and hunted fish beneath the water. Walruses gathered in coastal areas where they searched for shellfish on the seafloor using their sensitive whiskers. Their long tusks helped them pull themselves onto ice and defend against danger. Whales travelled through the oceans during the Ice Age, much as they do today. Some species migrated between feeding and breeding grounds over great distances. Others remained in colder waters throughout the year. They fed on fish, squid, or tiny marine animals, depending on the species. Their thick layers of fat protected them from cold ocean temperatures. Polar bears occupied Arctic coastal regions where sea ice allowed them to hunt seals. They depended heavily on the presence of sea ice because it provided access to their main food source. Their white fur, thick body fat, and large feet helped them move across frozen surfaces while staying warm in harsh conditions. Human beings also became part of Ice Age ecosystems. Early humans lived in many different parts of Europe, Asia, Africa, and later North America. They depended closely on plants and animals for survival. They gathered berries, roots, nuts, seeds, edible leaves, and fruits whenever these foods were available. They also hunted animals of many sizes, from rabbits and birds to deer, horses, and sometimes mammoths. Fish from rivers and lakes became another valuable food source. Early people learned which plants could be eaten safely and which ones should be avoided. This knowledge was passed from one generation to the next. They collected wood for fires, branches for shelters, grasses for bedding, and animal skins for clothing. Bones became useful materials for making tools, needles, fishing equipment, and other everyday objects. The changing seasons shaped the lives of both humans and animals. During spring, melting snow supplied water to rivers and encouraged new plant growth. Many animals gave birth during this season because food became more plentiful. Birds built nests, insects became active, and fish moved into rivers to reproduce. Summer brought the greatest abundance of plant life. Flowers bloomed, grasses reached their full height, and forests produced fresh leaves. Animals spent long hours feeding to build strength and store body fat. Autumn marked a time of preparation. Trees dropped their leaves, many plants produced seeds, berries, and nuts. Animals gathered food, stored fat, or migrated toward areas where winter conditions would be less severe. Birds prepared for long journeys, while mammals grew thicker coats. Winter created the greatest challenges. Snow covered much of the ground, making food harder to reach. Many animals reduced their activity to save energy. Others remained active throughout the season, using their physical adaptations and learned behaviors to survive. Predators continued searching for prey despite the harsh weather. Rivers sometimes froze at the surface, although flowing water often remained beneath the ice. Glaciers influenced plant and animal life in many ways. As glaciers slowly advanced, they covered forests, grasslands, rivers, and valleys beneath thick layers of ice. Living things moved into surrounding regions whenever possible. When glaciers later retreated, newly exposed land gradually became occupied by mosses, lichens, grasses, shrubs, and eventually forests where conditions allowed. Animals slowly returned as food sources became established. Climate changes occurred many times during the Ice Age. Some periods became colder while others grew somewhat warmer. Plants shifted their ranges as temperatures and rainfall changed. Animals followed the movement of suitable habitats. Species that depended on open grasslands expanded when those environments increased. Forest animals spread into new areas whenever trees became more widespread. The relationships between plants and animals remained essential throughout the Ice Age. Plant-eating animals depended directly on grasses, shrubs, leaves, bark, mosses, lichens, and flowering plants. Hunting animals depended on healthy populations of plant-eaters. Insects pollinated flowers and became food for birds, fish, reptiles, amphibians, and mammals. Dead plants and animals were broken down by fungi, bacteria, and other small organisms, returning nutrients to the soil where new plants could grow. Not every Ice Age animal survived until modern times. As climates continued changing toward warmer conditions, many large mammals gradually disappeared from different parts of the world. Scientists continue to study the reasons for these extinctions. Evidence suggests that changing environments reduced suitable habitats for some species. Human hunting may also have affected certain animal populations in some regions. The exact importance of each factor likely differed from place to place and from one species to another. Many Ice Age plants continued living after the great ice sheets retreated. Forests expanded into areas that had once been covered by tundra. Grasslands remained important in many regions. Mosses, lichens, shrubs, and flowering plants continued growing across northern landscapes. The descendants of these plants still form important parts of modern ecosystems. Many surviving Ice Age animals also remain part of today's natural world. Reindeer still travel across northern lands. Muskoxen continue living in Arctic regions. Brown bears, wolves, foxes, beavers, otters, hares, deer, bison, and countless birds, fish, and insects still occupy environments that resemble those used by their ancestors during the Ice Age. During the Ice Age, early humans lived in a world that was much colder than today. Large parts of the Earth were covered with thick sheets of ice, and many places that are now filled with forests Farms and cities were frozen for very long periods. The weather changed with the seasons, and people had to deal with freezing winters, cold winds, heavy snowfall, and short summers. Even though these conditions were difficult, early humans did not disappear. They learned how to live in this harsh environment by observing nature, working together, making useful tools, building safe shelters, controlling fire, finding food, and passing knowledge from one generation to the next. The Ice Age did not mean that the whole Earth was covered with ice. Many areas remained free of permanent ice, although they were still much colder than they are today. These lands included open grasslands, rocky valleys, riverbanks, and areas with scattered trees. Many large animals lived in these places because they could find enough plants to eat during the warmer months. Early humans often settled close to these animals because they depended on them for food, clothing, tools, and shelter materials. Finding enough food every day was one of the greatest challenges. Early humans could not visit farms or stores. They had to search for everything they needed. They hunted animals, gathered wild plants, collected roots, dug up edible bulbs, picked berries during the warmer seasons, and searched for nuts wherever they grew. They also caught fish from rivers and lakes and looked for shellfish along coastlines when they lived near the sea. Every source of food was valuable because long periods of cold weather made it difficult to find fresh plants. Large animals played an important part in helping humans survive. Early hunters followed herds that moved across open land in search of food. They hunted animals such as woolly mammoths, woolly rhinoceroses, wild horses, bison, giant deer, reindeer, musk oxen, and other animals that were able to live in cold conditions. Hunting these animals required planning, patience, courage, and teamwork. A successful hunt could provide enough meat to feed many people for days or even weeks. Hunting was never easy. These animals were strong, fast, and dangerous. A wounded animal could injure or kill a hunter. Because of this danger, people rarely hunted alone. Groups of hunters worked together and shared different jobs. Some quietly followed animal tracks. Others watched the direction of the wind so that animals would not smell them. Some guided animals toward places where they could be trapped more easily, while others waited with weapons ready. Working together increased the chances of success and reduced the risk faced by each person. The meat from hunted animals gave people important nutrients and energy. During very cold weather, the human body needed enough food to stay warm and remain active. Fresh meat could be cooked over a fire and eaten immediately. Extra meat could be dried in the cold air or smoked over slow fires so that it lasted longer. Storing food helped families survive when hunting became difficult or when animals moved away for a season. Almost every part of a hunted animal had a useful purpose. Thick skins became warm clothing, blankets, and coverings for shelters. Bones were shaped into needles, fishing hooks, spear points, knives, and other useful tools. Antlers became strong handles and digging tools. Animal sinews were used as thread for sewing clothes and tying tools together. Fat was used as fuel for lamps, cooking, and sometimes as food when other supplies were limited. Nothing useful was wasted because replacing these materials was not always easy. Clothing became one of the most important parts of survival. Early humans understood that bare skin could not remain exposed to freezing temperatures for long periods. They learned how to clean animal hides, remove unwanted parts, soften the skin, and sew different pieces together to make warm clothing. They made coats, trousers, boots, gloves, hats, and coverings for their feet. These clothes trapped body heat and protected people from cold winds and snow. Bone needles allowed people to sew clothing more carefully than before. Small holes could be made through thick animal skin, and sinew could be passed through these holes to hold different pieces together. Clothing that fitted well helped people move more easily during hunting and travel, while also keeping them warm. Children and older people especially benefited from carefully made clothing because they were often more affected by cold weather. Shelter was another important part of survival. A person without protection from freezing winds and snow could quickly become weak from the cold. Early humans looked for natural shelters whenever possible. Caves provided protection from rain, snow, and strong winds. Rock overhangs also gave some protection. These places often became homes for groups of people during certain times of the year. Not every group had access to caves. In places without natural shelters, people built homes using materials they found nearby. Wooden branches formed the main frame of many shelters. Animal skins covered the outside to keep out cold air. In places where large mammoth bones were available, some groups used these strong bones as part of the structure. Grass, moss, leaves, and other natural materials were packed into gaps to reduce the amount of cold air entering the shelter. Inside these shelters, people organized their living space carefully. A fireplace often stood near the center, allowing warmth to spread through the shelter. Sleeping areas were covered with animal skins to reduce heat loss from the cold ground. Food, tools, weapons, and clothing were kept in places where they could be reached easily. Keeping the shelter clean also helped reduce disease and made daily life more comfortable. Fire was one of the greatest discoveries that supported survival during the Ice Age. It gave warmth during freezing nights and cold winters. Fire allowed people to cook meat, making it easier to chew and digest. Cooking also helped destroy many harmful germs that could be present in raw food. Fire provided light after sunset, allowing people to continue making tools, repairing clothing, preparing food, and sharing stories. Fire also protected people from many dangerous animals. Large predators often stayed away from bright flames and smoke. This gave families greater safety while sleeping. Hunters could also carry burning sticks while traveling at night, or use smoke to drive animals from certain areas during hunts. Keeping a fire burning required constant attention. Dry wood had to be collected whenever possible. During snowy weather, finding suitable firewood became more difficult. Families often stored wood inside or near their shelters so that they always had enough fuel. Someone usually watched the fire carefully to prevent it from going out, because starting a new fire could take time and effort. Early humans became skilled tool makers. Their tools became better over many thousands of years. Stone remained one of the most important materials because it was strong and could be shaped into sharp edges. Flint was especially useful because it broke into very sharp pieces. Hunters made spear points, knives, scrapers, and cutting tools from carefully shaped stone. Wood also remained useful. Spears often had wooden shafts with sharp stone points attached firmly using natural glue and sinew. These weapons helped hunters attack animals from a safer distance. Digging sticks helped gather edible roots from frozen or hard ground. Clubs, carrying poles and other wooden tools supported everyday work. Bone tools became increasingly common because large animals provided plenty of bones after successful hunts. Bones could be shaped into needles, fish hooks, spear tips, smoothers for preparing hides, and many other useful objects. These tools made daily work easier and allowed people to produce better clothing and equipment. People also developed new hunting methods. Instead of depending only on strength, they used careful planning. Hunters studied animal tracks left in mud, snow, or soft ground. They learned to recognize different footprints and could often tell which animal had passed, how many animals were present, and how recently they had been there. Broken branches, animal droppings and disturbed grass also provided useful information. Knowledge of animal behavior increased hunting success. Hunters observed where animals drank water, where they rested, where they gave birth, and where they searched for food during different seasons. This understanding helped hunters know the best places and times to hunt. Travel formed another important part of life. Early humans did not always remain in one place throughout the year. As seasons changed, animals moved to find fresh food, and people often followed them. Rivers, valleys, and open grasslands became natural travel routes because they provided water, food, and easier walking conditions. Food gathering remained important throughout the Ice Age because hunting alone could not always provide enough to eat. During warmer seasons, people searched for berries, fruits, nuts, and edible plants. They dug up roots buried beneath the soil and collected seeds that could be eaten or stored for later use. Even small amounts of gathered food helped families survive when hunting was unsuccessful. Fishing also became an important source of food in many places. Rivers, lakes, and coastal waters contained fish that could be caught using simple tools. Bone hooks, sharpened wooden spears, woven traps, and nets made from plant fibers helped people catch fish. Fish provided valuable food during seasons when large animals were difficult to hunt. Life on Earth changed greatly as the Ice Age slowly came to an end. For thousands of years, many large animals had lived across cold grasslands, open plains, forests, valleys, mountains, and frozen regions. These animals had survived long periods of freezing weather, heavy snowfall, and strong winds. Their bodies had slowly changed over many generations to help them live in places where food was often limited during the coldest seasons. Thick fur, heavy layers of fat, large bodies, and other special features helped many of them survive in these difficult conditions. Even with these useful features, many Ice Age animals disappeared from the Earth after the climate began to change. Their extinction did not happen all at once. It happened over a long period as many different events affected their lives. The Ice Age was not a single period of endless cold. During this long part of Earth's history, temperatures rose and fell many times. Large sheets of ice spread across huge areas of land during colder periods and then slowly melted during warmer periods. These natural changes affected rivers, lakes, forests, grasslands, coastlines, and many other parts of the environment. Every living thing had to adjust to these changes. Some animals adapted successfully, while others struggled to survive. One of the main reasons many Ice Age animals became extinct was the gradual warming of the climate. As temperatures slowly increased, the giant ice sheets began to melt. This melting changed the shape of the land in many places. Rivers became larger, lakes formed in new areas, and sea levels slowly rose as more water flowed into the oceans. Places that had once been cold and dry became warmer and wetter. These changes affected the plants that grew in different regions. Many large Ice Age animals depended on wide grasslands filled with special kinds of grasses, herbs, and small flowering plants. These plants grew well in cold and dry conditions. As the climate became warmer, forests slowly spread into many of these open areas. Trees, bushes, and different kinds of plants replaced much of the grassland that had provided food for large grazing animals. As their food sources became smaller, these animals had to travel farther in search of enough food. Finding food became harder for many species. Large animals needed large amounts of food every day. Mammoths, giant bison, giant deer, woolly rhinoceroses, and several other animals spent much of their time eating. When the amount of suitable plants became smaller, they had to compete for the remaining food. Older animals, young animals, and weaker members of the group often found it difficult to get enough to eat. Hunger reduced their strength and made survival much more difficult. Changes in plants also affected animals that hunted other animals. Large meat-eating animals depended on healthy populations of plant-eating animals. When grazing animals became fewer, predators also struggled to find enough food. Lions, wolves, saber-toothed cats, short-faced bears, and other hunters had to search over larger areas for prey. Some were unable to find enough food to raise their young successfully. The warming climate also changed the seasons. Snow melted earlier in many places. Rainfall patterns slowly changed. Some areas became wetter, while others became drier. Plants that had grown in one place for thousands of years slowly disappeared and were replaced by different kinds of vegetation. Animals that depended on certain plants often found that their favorite food was no longer available. Many Ice Age animals had become highly suited to cold weather over thousands of generations. Thick coats kept them warm during freezing winters. Heavy bodies helped them keep heat inside. Some had shorter ears and tails that reduced heat loss. These features were useful during very cold periods. As the climate became warmer, these same features sometimes became less helpful. Thick fur could make warm weather more difficult to tolerate. Animals had to spend more energy keeping cool while also searching for food. Moving into cooler regions was not always possible. Some animals slowly traveled farther north as temperatures increased. Others climbed into higher mountain areas where cooler conditions remained. These new habitats were often smaller than the open lands they had previously occupied. Smaller habitats supported fewer animals. As living space became limited, populations slowly became smaller. Small populations faced many problems. When fewer animals remained, finding mates became more difficult. A disease could spread through the remaining group and remove many individuals. Natural disasters such as floods, storms, harsh winters, or droughts could affect a large part of the population at once. With fewer animals left, recovery became much slower. Human beings also became an important part of the story. During the later part of the Ice Age, modern humans spread across many parts of Europe, Asia, Africa, Australia, and the Americas. These people were skilled hunters. They worked together in groups, planned their hunts carefully, and created tools that made hunting more successful. Stone spear points, sharp cutting tools, throwing weapons, and later inventions helped people hunt animals much larger than themselves. Early humans depended on animals for many parts of daily life. Meat provided food, hides became clothing and shelter coverings. Bones were shaped into tools, needles, fish hooks, and other useful objects. Ivory from mammoth tusks was carved into tools, decorations, and works of art. Every successful hunt helped families survive difficult seasons. Some scientists believe that hunting by humans placed great pressure on certain animal populations. Large animals usually had long lives, but produced only a small number of young. A mammoth mother, for example, needed many years to raise a calf before giving birth again. If adults were killed faster than young animals could replace them, the population slowly became smaller over many generations. Not every hunt ended successfully. Large Ice Age animals were powerful and dangerous. Mammoths could defend themselves with long tusks. Woolly rhinoceroses had strong horns. Giant bison were fast and heavy. Hunters faced serious risks whenever they approached these animals. Careful planning and teamwork were necessary. Even so, many hunting trips probably failed or ended with injuries. Human populations slowly increased over time. As more people settled across different regions, hunting took place over larger areas. Animals that had once lived with little contact with humans now encountered hunters more often. Some species may have found it difficult to recover from this added pressure while also dealing with changing climates and shrinking habitats. Fire also became an important tool for humans. People sometimes used controlled fires to clear land, improve hunting opportunities, or encourage the growth of fresh plants that attracted grazing animals. Although these fires were usually much smaller than natural wildfires, they still changed parts of the landscape. Repeated burning over long periods may have affected local plant communities in some places. Disease may also have played a part in the extinction of some species. Germs that spread among animals can sometimes reduce populations very quickly. A disease that affects one group can move into another if animals come into close contact. Scientists continue to study this possibility because direct evidence is difficult to find after such a long time. Disease alone probably did not cause all the extinctions, but it may have added pressure to animals that were already facing many other challenges. Some animals depended on very specific environments. They could not easily switch to different foods or different habitats. When those environments disappeared, survival became much harder. Animals with more flexible diets often had a better chance of adapting. Those that could eat many kinds of plants or hunt different prey sometimes continued to survive even as conditions changed. Reproduction was another important factor. Large animals usually needed many years to reach adulthood. They often gave birth to only one baby at a time. Parents spent a long period protecting and feeding their young. If many adults died before producing enough offspring, the total population slowly declined. This process could continue for many generations before the species finally disappeared. Extreme weather events also created difficulties. Even during periods of overall warming, very cold winters could still occur. Heavy snowfall sometimes covered the plants that grazing animals needed. Thick ice could form over grass after freezing rain, making it impossible for animals to reach their food. Weak animals often died before spring arrived. Floods caused by melting glaciers changed many river valleys. Fast-moving water reshaped the land and created new lakes. Some migration routes used by animals for many generations were blocked or changed. Wet ground replaced dry grassland in some places, reducing the amount of food available. Rising sea levels also changed the world. As glaciers melted, the oceans slowly expanded across low coastal lands. Land bridges that had once connected continents disappeared beneath the sea. Animal populations became separated from one another. Once isolated, they could no longer mix with other groups. Smaller, isolated populations became more vulnerable to extinction because fewer animals remained in each area. Genetic diversity also became lower as populations shrank. Healthy populations usually contain many different genetic traits. These differences help species survive changing conditions. When only a small number of animals remain, genetic diversity becomes smaller. Harmful inherited traits may become more common, and the ability of the species to adapt to new challenges becomes weaker. Scientists studying ancient DNA from Ice Age animals have found evidence that some populations experienced reduced genetic diversity before they disappeared. Predators also faced serious problems when prey animals became scarce. Saber-toothed cats depended on large herbivores for food. Dire wolves hunted in groups and relied on sizable prey. Short-faced bears required large amounts of food to support their massive bodies. As herbivore numbers declined, these predators often struggled to survive. Some may have turned to smaller animals, but this did not always provide enough food to support their needs.